How much power do you think you need in any bike? Is it all about speed, torque, or range? You're looking at one of the most powerful e-bikes on the market today. This is the WiredFreedom. The electric motor peaks at 3,200 watts. It can reach speeds of 40 miles per hour. It delivers a whopping 153 newton meters of torque and can travel distances of 100 miles or more on a single charge. Yes, this bike is a beast and oh so much fun to ride. But is there such a thing as too much power? Why would you even want this much power in an e-bike? Is an extreme powered electric bike like the WiredFreedom the right fit for you? In this segment of the Complete E-Bike Guide series, we're focused on the electrical components that make up the power delivery system of any e-bike. By the end of this video, you should have a solid understanding of how the power systems work and what to consider when it comes to power in your next e-bike purchase. Before we start, I want to give you a quick update on Wire e-bike's lineup. I'm using the WiredFreedom Plus as the demo bike today, but this model has just been updated for 2025. It is now called the WiredFreedom 60 volt. It has the same motor and power specifications, but with a newer frame design, including a stronger rear rack, a front rack mount, upgraded cadence torque sensor, and some cool new software updates. Check it out at wiredebikes.com. Now, most electric bikes on the market today are powered by one of two types of motors. It's either a hub drive motor or a mid-drive motor. The most common is the hub drive. They both have their advantages, but probably the biggest advantage of a hub drive motor is its cost. It's just cheaper to manufacture than a mid-drive motor and, to be honest, a bit easier to operate for the beginner. A hub drive motor spins the wheel via the hub, independently of the drivetrain. You can of course pedal, but as long as you have a throttle, the motor does not need you to pedal to operate. A mid-drive motor, like this heybike Alpha, is a more traditional bike riding experience, requiring the use of the drivetrain and selecting the proper gears on the rear cassette hub. This will be one of the first decisions about power you make when selecting your next e-bike, hub or mid-drive motor. All of Wired's bikes utilize a high-powered geared hub drive motor designed exclusively by the Chinese company Hengtai. Wired does not currently offer a bike with a mid-drive motor, nor do most e-bike manufacturers at this price point. Heybike is one of the few who do. The Alpha is a 48 volt system rated at 500 watts continuous and a top speed of 28 miles per hour. It offers 105 newton meters of torque, which is a benefit of a mid-drive motor, higher torque for a smaller motor. The WiredFreedom hub motor is a 60 volt system. When the batteries are fully charged, it actually delivers 67.2 volts, but will quickly level off and average out at about 60 volts. This is why they call it a 60 volt motor. It will then shut off once it reaches under 50 volts, which is called the low voltage protection limit, which is set by the controller. Basically, when the volts drop below 48 volts on a 60 volt system, the motor just doesn't have enough energy force to spin the wheel. So to protect the motor, the controller cuts off the power. We're going to discuss the controller in more detail shortly, but a key concept to understand about any electric motor is how it handles the power sent to it, and understanding how the volts and the amps work together will give you a better understanding of a motor's power capabilities. Next, let's go over volts, amps, and watts. Every e-bike motor operates on a certain amount of volts and amps. Watts are simply volts multiplied by amps and represent a power rating number. Every e-bike will list the volts of its motor. You will see 36, 48, 52, 60, or 72 volts. And then as you get into the more powerful e-moto style bikes, you will see 84 volts and higher. But the most common are the 48 and 52 volt systems. Volts are the force or pressure being sent to the motor. The higher the volt number, the more electrical force being sent. Therefore, a 60 volt system is forcing or sending energy into the motor significantly faster or more pressurized than a 48 volt system. The amps represent the flow or current of the electricity. This number basically represents how much electricity flows to the motor at any given time. Amp hours represent how much electricity is stored in the batteries. If you multiply the volts times the amps, you get watts. If you multiply the volts by the amp hours, you will get watt hours, or a total amount of watts per hour of use. This will then give you an idea on how long a motor will operate at any given watts output. So, if you are using 500 watts per hour and your battery stores 2,000 watt hours, You would then have 4 hours of ride time, assuming you don't go over that 500 watts per hour. I have the Freedom's Hengtai 1500 watt motor core out of the housing, so you can take a closer look. This is a geared hub drive motor. There are also direct drive motors. The difference is that geared hub motors have internal gears. The use of gears increases torque at takeoff. You get more off-the-line power than with a direct drive motor. But once at speed, direct drive motors operate a bit more efficiently, just slower at launch. The WiredFreedom's motor, like most, is a planetary geared system. What does that mean? Well, there are 3 planet gears here, attached to a clutch assembly. They rotate around a metal sun gear that is attached to the drive shaft. The outer planet gears help more evenly distribute the force coming from the sun gear, which translates into more torque. You'll also notice the planet gears are steel nylon hybrid design. This is due to the size and power of the motor. When you have a motor rated to peak at 3200 watts, your gears have to be strong enough to handle that power and the heat it generates. This is part of that design, which makes them 5 times stronger than nylon-only gears. Definitely better at resisting heat and should last for thousands of miles under normal use conditions. Is there a downside to these metal hybrid type gears? No, not really. They weigh a little bit more and can be a little louder than nylon gears. And then compared to a direct drive motor, there are more moving parts, but that's about it. So a small price to pay for the increase in power and longevity. Now let's move on to the next major component of the power delivery system, and that's the controller. This is what the WiredFreedom Plus controller looks like. I have it unhooked from the bike so we can take a closer look. The quality and performance of the controller can't be understated. It's basically the brain or central processing computer of any e-bike and controls sending electrical energy from the batteries to the motor. This controller is made by Patriot, and again, this one is rated at 60 volts with a max output of 45 amps, but actually can achieve closer to 48 amps during peak demand, assuming you're using both batteries and they are fully charged. So let me explain this a little differently. The controller will send in high demand situations approximately 48 amps to the motor, and if your batteries are fully charged to 67.2 volts, you will then achieve the 3200 watts peak output. This usually happens when you fully accelerate from a full stop or are on a hill. You can actually see this on your display while it's happening. This is the maximum burst of power the motor can handle. But the nominal or continuous current rating is more like 22 amps. This is the amount of amps the motor can operate on that doesn't cause overheating or excessive wear. When you multiply 67.2 volts by 22 amps, you get 1500 watts. Well, they round up a little bit. So, a key takeaway in all of this is to understand the controller is what dictates the amount of electricity delivered to the motor and the amount of power it will then output. Now, the motor has a range of power it can handle, but the controller is what regulates that power output, not the motor. The controller also controls the display, so it manages the software and the user interface for the e-bike. And along with the thumb controller, twist throttle, pedaling sensors, so either cadence or torque, and brakes, it allows you to properly operate and control the motor and batteries. Wired recently upgraded the controller for all their bikes, so they are now internally potted and sealed. Now, if you have not heard of potting, this is what it looks like. In its simplest form, it's adding a thermal sealing compound to the internal components of the controller, creating an insulation. It also enhances the mechanical strength, allows for more efficient heat dissipation, increases resistance to vibration and shock, and protects the internal components from outside moisture. Let's move on and discuss weight. Weight is a significant factor on how an e-bike performs when it comes to speed, torque, and range. The weight of the bike, your weight, and the weight of your cargo and accessories all add up and will impact the efficiency of the ride. The best thing you can do to achieve maximum efficiency is simply to lighten the load as much as possible. Only carry what is necessary and watch out on how many accessories you add. Those add-ons can really increase the weight of the bike. All right, there you go. You now have a solid understanding of how the power system of an e-bike works. You should be able to make some decisions on what is enough power for your riding preferences. If speed and torque are your thing, you will need to go with a higher voltage bike, the higher powered motor, like the Wired's line of bikes. The controller is probably the most important component of the power delivery system. Look at the specs and make sure it will deliver the power you want. Just because the motor is rated at higher wattage does not mean the controller will deliver that power. You need to check the specs on the controller. Lastly, if you want the best performance and speed, you need to limit the amount of weight you add to the bike. The heavier it is, the more work the motor has to do. So limit your accessories and make sure your batteries are operating at their full capacity. In the next video of the Complete Guide series, I'm going to cover how do we get the best range out of an e-bike, including a complete detailed breakdown on the batteries and controlling the pass system to get maximum range. So stay tuned for that. If you're considering buying a wired bike, use the link below. It doesn't cost anything extra and will support this channel, allowing me to continue to make these videos for the future. And again, please click that like and subscribe button, comment, share with friends, and follow all my other social media accounts. It really does help reach more viewers like you. Thanks again for watching. You're awesome, and see you on the next one.